Hello, everyone. My name is Michel Trudeau. I work at Oracle in the Java language team. I'd like to talk to you today about what we're working on in our area, some language features and tooling features. So first, I'd like to talk about some language enhancements and tooling that we are responsible for, and we've been doing in the last four 6-month releases since JDK 10. Each of the releases contains a little bit of features, but cumulatively, it becomes more and more interesting. But first, I'd like to do a poll just to find out in the room who's using JDK 8. Okay, most people. Who's using JDK 11? Oh, that's pretty good. Okay, and JDK 12? Okay, well, a little bit more people. Okay, that's good. So most people are on JDK 8, and quite a few of you are on JDK 11. And the nice thing is, from 9 on, it becomes increasingly easier to migrate from one release to another, as there are fewer changes and there are a lot more control over what's going in, and there are less breaking changes, essentially. Some of the features that I talked about were mentioned in the keynotes. I'm going to go into a bit more detail, and so a little bit of advertisement here. If you want to use JDK, the latest JDK, it's available at that website. Today we're announcing JDK 13. It's available to be downloaded, and if you want to download any other builds, early access builds, or special feature builds such as Loom, OpenJFX, Panama, etc., you could download them from that website. They're not production build. Only JDK 13 here is the production build. Starting with language enhancements, I'll focus more on the language feature available today, and I'm going to also touch base on some of the language on our roadmap, language features on our roadmap. Starting with the first feature, in JDK 10 we introduced local variable type inference. So that's enhancing the Java language to extend type inference to declarations of local variables with initializers. The goal here is to improve developer experience by reducing some code ceremony associated with declarations. Looking at these examples here, as you could see, the type can be inferred from the right-hand side by the initializer. And therefore, repeating the same type on the left-hand side becomes noisy, let's say. var shouldn't be used for every cases, but there are cases where it's very useful and it's perfectly fine. And also, var is available for formal parameter of implicitly typed lambda expression. So reading is more important. Reading code is more important than writing code, and therefore var must be properly used. We provide a style guideline and a FAQ at those links to describe extensively how var should be used. And there was a presentation, or there is a presentation as well at Oracle Code One from Stuart Marks, who goes very deep in the details of var. So, but I'd like to talk about some of the most important guidelines, 3 of them essentially. So the first one, it's about choosing a variable name that provides useful information. In general, it's a good practice, but in the context of var, it's even more important. In the variable name, we can encode a lot of information. So as an example below, a database connection, when we execute a query, it returns a result. And this result, we could assign it to a variable name that's very descriptive, such as customer list, or we could use some X, Y, Z, which are not very descriptive. As you could see, when you use something meaningful like customer list, using var is very convenient. It's not very descriptive to say, oh, it's of type list of customers. Same thing for other kind of results that could be returned by a database connection, such as customers, instead of just calling this result, as I often see in JDBC or other database application. A second guideline here is to consider var when the initializer provides sufficient information to the reader. Local variables are often initialized with a constructor or a factory method call. here, as a first example, you have a local variable, an output stream, which is initialized with a call to a constructor called byte array output stream. Repeating the same type on the left-hand side becomes noisy. var is very convenient here, and output stream is clear enough to be used throughout the method without having to refer most of the time to what the type of that variable was. Same thing for factory method calls, such as new buffered reader and list of. Using var makes it very convenient, clear, and also for those who like the aesthetics of typing code, it helps you align your list of local variables. A third one, it's got to do with complex lambda expressions. Here I've got a complex expression, which is not really complex. It's only 4 lines, but my slides are not very big. But it's often the case that lambda expression could be 10 lines and sometimes even more. And therefore, breaking them sometimes make things a little bit more clear. But when you break them, you're going to realize quickly to try to figure out the return type of your partial lambda expression might be complex. So using var in that case is very convenient. So here is an example where I've got a list of blocks, and some of them are blue, and I want to find the one with the heaviest of the blue blocks. So first I could simplify my pipeline by extracting first the blue blocks, and then figuring out the maximum weight of these blue blocks. And I don't have to worry about what is the type returned by that filter method there, using var. Next language feature I'd like to talk about is actually a preview language feature in JDK 13. So before talking about this next feature, I'd like to introduce a concept of previews. So we have introduced this in JDK 11. So a preview language or VM feature is a new feature of the Java SE platform that is fully specified, fully implemented, but not permanent. And to use a preview feature, you need to use the --enable -preview flag, command line argument on the tools. Or if you're using an IDE, NetBeans, IntelliJ, and these other IDEs are providing very good support for preview features by now. The other upside for us of providing a preview feature is that it helps us with the faster release cadence of 6 months. So 6 months comes very, very quickly, and it helps providing a feature as a preview first so that in the real world, if we didn't get it completely right, we have a chance to fix it. And by introducing the first preview feature, switch expression, it's a case in point here. We've introduced first in 12. And then after real-world example, we realized that the feature was not yet quite perfect. So we made one more change, and we reintroduced it in JDK 13 as a preview feature again. So the switch expression, it's extending the switch statement so that it can be used as either a statement or an expression, and that both forms can use a traditional or simplified scoping and control flow behavior. These changes will simplify everyday coding. So the goal here is to fix several irregularities of the existing switch statement, which includes the default control flow behavior fall through of switch blocks, the default scoping of switch blocks, and the fact that switch is available only as a statement. In Java, the switch statement is modeled after C and C++, which is very old, and it's got fall through semantics by default. And while this was quite powerful and very convenient to write very low-level code, in higher-level application, it's more error-prone in nature, and its super flexible benefit starts to outweigh its flexibility here. So we're fixing this. And to talk about it, I'm going to go through some examples and the feature of the switch expression. So here's an example here where many switch statements are essentially simulations of switch expressions. So here, each arm assigns to a common variable, and then this variable is used after the switch statement to perform some additional operation. Here's a nicer way to write the same code. And with this little snippet of code, I'm actually presenting all the features of this new switch expression. So first, there's a new form for the case statement with an arrow instead of a column. Second, with this new form, there are no more breaks needed. Third, you could specify one or more labels on each case statement. Like the first case statement, we have three labels. Before we had to say case Monday column, case Friday column, etc. And you could use the switch statement as an expression. On the right-hand side of this arrow, you can only have the following type of statement: an expression, a block statement, or a throw exception. So the switch expression raises additional requirements since every case arm must compute a value of compatible type or throw an exception. So the code here that I'm showing is safer as there's no chance to forget a break and there's no chance of falling through. So the target type, a switch expression is a poly expression. If the target type is known, this type is pushed down into each arm and type check is enforced. The type of a switch expression is its target type, if known. If not, a standalone type is computing by combining the types of each case arm. In that case, the target type is not known. We're using var. Therefore, we need to look at the type of each case statement. And the type of each case statement in that example is fairly simple. Therefore, for integers. If one of them would be something not compatible with an integer, an error would be raised by the compiler. And all the standard coercion conversion type applies here. About yielding a value. So most switch expression will have a single expression to the right case, to the right side of the arrow. In the event that a full block is needed, we're using yield with an argument which becomes the value of the enclosing switch expression. So in that case, in the default case, it's a little bit more complex than just like a simple expression. We have a block, but we need to return a value to the switch expression from that block. We do this using the yield statement. So a switch expression can, like a switch statement, also use the traditional switch block with case statements, the old case statement type with the column and the break and all that. In this case, values would be yielded using the yield with value statement. But we don't believe people will resort to this old form of case statement to write switch expression. But it's available. It's part of the language. Another aspect of switch expression is the case of a switch expression must be exhaustive. For any possible value, there must be a matching switch label. This means that by default, a default clause is required, except for the case of an enum switch expression that covers all known case. In the first example, we're switching on an integer. So therefore, well, it's most likely impossible to specify all the integer values here. So therefore, there needs to be a default case. If not, if there's no default statement, it's an error. The second one, we're using only 2 of the enumeration from the days of the week. So therefore, we also need a default case. Furthermore, a switch expression must complete normally with a value or throw an exception. This has a number of consequences. The compiler checks that for every switch label, if it is matched, then a value can be yielded. Here's some example where in case Monday, I have a block and I'm doing some processing in my block, but I'm not returning anything. That's a compiler error. Same thing in the second example in the default case where I'm not returning anything for my switch expression. So in summary, here are some of the advantages of the switch expression feature. It provides exhaustive coverage of case statements. It improves the scoping rules and less needs for temporary locals. There's no fall through on the right-hand side of the case statement. And there's a choice of using an expression or a block statement on the right-hand side. So another preview feature we have in JDK 13 are text blocks. So a text box is a multi-line string. A literal that avoids the need for most escape sequences automatically formats the string in a predictive way and gives the developer control over format if desired. This new JEP replaced raw string literal, which we talked about in previous Oracle Code 1. Raw string literal has been withdrawn. So here's an example of how a multi-line string was done in Java previously. I've got this little HTML snippet of code, properly indented, but still a small snippet of code where, and then on the right-hand side, I got the same literal, but using multi-line strings, text blocks. So by passing it between a pair of triple double quotes, the code is equivalent on the left side, and it's more readable and much easier to code. There's no need to add a \n on each line, to surround this by single double quotes on each, and to add the plus sign, the concatenation operator. And the result is the same. It's a string literal. So it's a great way to insert snippet of code or text in the source code while preserving indentation. So I mentioned formatting and indentation. We are providing some additional method in the string library to perform additional processing on text blocks, but by default, there are some built-in formatting, a minimal built-in formatting. So moving to a multi-line format, it left us with a dilemma. We want to indent the text block along with our code, but we probably don't want the incidental indentation to show up in the string. We use the position of the closing delimiter to determine which indentation is essential and which one is accidental, and we trim off the accidental indentation. In this example below, all the gray dots indicate which indentation was deemed accidental and will be removed as part of it. So this was a little bit complicated to explain, but I'd like to do just a little demo just to show you how this accidental versus essential indentation works here. Hopefully that's going to work. All right, that works. Okay, so I got a JShell session here, and I've got a simple multi-line string that I'm printing. So if I print that multi-line string, as you could see, all the extra white space at the beginning has been removed, but the indentation has been preserved. So to calculate this is essentially we take the line in the multi-line string that is the leftmost margin. In that case, body/body and the ending triple quotes are all aligned. But for example, since I mentioned that the closing delimiter was important in calculating that incidental space, if I just space this one in just by one character, the result is that I have a one space in the beginning of every single line in my multi-line string. If I bring my closing delimiter all the way to the beginning, whoops. Okay, I made a mistake here, so. All right, sorry about that. That should be simpler. Then here, as you could see, all the left margin space becomes significant, becomes part of the string. All right, going back. Good. So next, I'd like to talk a little bit about the features that are on our roadmap that is coming in the near term, hopefully. So the first feature is records. So records provide a compact syntax for declaring classes that are nothing more or mostly plain data carriers that serves as simple aggregates. I've got an example of a record right there. It's a point, and it's containing two components, X and Y. And therefore, this is a full record declaration. But the records acquires many standard members automatically. So there's some code generated as part of those records here. And some of the code generated is there's a private final field for each component. There's a public read accessor for each component, and a public constructor, and an implementation of equals hashcode and toString. So on the next slide, I'm going to show what all this generated code looks like, essentially. So we have a constructor, we have an implementation of equals, hash code, and toString, and we have our two public accessors for our X and Y. And these X and Y are immutable. They cannot be changed. The next feature I'd like to introduce is seal types. So they are classes or interfaces that impose restrictions on which other classes or interfaces may extend or implement them. As an example here, I've got a node, which is a seal type. And with the implicit permits clause here, it specifies that node may be extended only by the types enumerated by that clause, which is A, B, and C. And furthermore, these members must be in the same module, or if node is in the unnamed module, in the same package. So sealing serves two distinct purposes. It restricts which classes may be a subclass of a seal class, and it also potentially enables exhaustiveness analysis at the use site, such as when switching over type patterns for an instance of a seal type. It's currently no longer available. It's currently not available to switch on a type pattern, but this is another feature that we are working on. Introducing the next feature, pattern matching. This is the first release of this pattern matching list of features. And what we are doing here is enhancing the enhance operator here to remove the need for a cast. So essentially, in the first example, this is standard Java code where I test that object is an instance of a string. And then if it is, then in my if statement, the first thing I need to do to use object as a string, I need to cast it to a string. So this new form that we're introducing is we're doing a test and a binding at the same time. So if object is an instance of a string, we're binding it to the variable name mentioned, which is S in that case. Therefore, if that test is true, in the if statement, you don't need to cast anymore, and you could start using S. So therefore, it reduces the number of casts you have in your application, makes your code shorter, makes your code safer, and simpler to read. Some of the tooling enhancements that we've been working on as well since JDK 10 is, one of them is launching a single file source code program. So introduced in JDK 11, it's enhancing the Java launcher to run a program supplied as a single file of Java source code, including usage from within a script by means of Shebang files and related techniques. So the motivation why we did this is to help learn Java, and it's also to write small utility programs, and it's also to provide a way to run directly from source, reducing some overhead of compiling and packaging. So we are essentially adding a fourth mode of running an entry point in Java. The first mode being you could run a class. The second one, you could run a jar that contains a main class. The third one is a module. And the fourth one is a source file directly. So the source file that you may want to run may have an extension or no extension at all. If it has got an extension, I assume it's going to be .java, but it could be something else if you really wanted to. So here's an example of running something without an extension, hello world. And dash source can be used to specify the source version of the source code. So here's an example how to run a single file source code with you could specify the dash source, and then you could specify dash enable preview, and my source file that I want to run is testing switch expression, which is a preview feature. Therefore, I need the enable preview flag. Source file is compiled to memory and executed. Therefore, there are no .class saved. And this is a little bit under the hood what's happening. Java, it's calling under the hood Java C, and it's generating the class file to memory, and then it's reading that class file from memory. And arguments can be specified to the source file. They're passed directly to the running class. Here, arg1 and arg2 are passed to hello world. So Shebang Files. On Unix-based system, there's a feature called Shebang File. This feature can be used to write small utility programs, and therefore now in Java. It is desirable to be able to run a program directly from source, and Shebang provides a mechanism for this, and it's available on Unix-based systems such as macOS and Linux. It's a mechanism provided by the operating system which allowed a single file program, whether it's in Python, in Perl, or in Java, to be placed in any conveniently named executable file whose first line begins with !! And which specifies the name of program to execute. So here's an example of a Shebang file. We call it hello world. And the first line starts with a ! And an !, and then the location of the Java launcher we want to run this application with, and with some additional command line argument to pass to the Java launcher if needed. And to execute this hello world, if you want to execute it by itself, you set the executable bit on the file, and then you can run it. Some additional things we've been doing in the tooling areas, we've been doing some JavaDoc improvements over the last few releases. So first, we have a JavaDoc search now. Second, we are HTML5 by default. We still support HTML4 with the -- HTML4 flag, but it's HTML5 by default. We've done over the last several releases several module improvements to better support the module system. We've also added features to manage broken links better. We have a cleaner, simpler navigation bar. There's no more previous, next, all classes, frames, and no frames, since it's a no-frame application now. And we're constantly improving accessibility. The JavaDoc documentation itself for the platform is almost perfectly accessible free now. And we provide a new Doclet API, much better supported and documented Doclet API and implementation. Eventually, the old Doclet API and implementation will be removed. And occasionally, we deprecate feature and we remove feature as well. So in JDK 10, we remove Java H. The same feature is available through the Java-C command line. You just need to use the -h command line argument. And in JDK 11, we deprecated two features, the Nashorn and JavaScript engine and the PAC200 tools and its API. These features are still available. You can still use them in 12, still use them in 13, but we're still having a plan to remove them soon when we're going to find a stable replacement for them. As well, before we remove these features, we will have to submit a new JEP, and we will have to socialize this JEP with the community that we are removing this feature. So it's not going to happen out of the dark. There's a process for this. So using the new features, like I mentioned, you could download the latest build, and as part of downloading the latest build on this JDK JavaNet page, we have release notes, we have the API JavaDoc for this new feature, and we have builds for Linux, Mac, and Windows 64-bit. It's easy for a release or a build to find the list of new features through the list of JEPs, but new releases of Java implements dozens, if not hundreds, of new enhancements as well that are not JEP. There are smaller enhancements, but that doesn't mean they're not very useful. And most of these enhancements that are worth noting and documenting are part of the release notes. The release notes are fairly large. They are well categorized. Inside the release notes, you're going to have a section for new feature, a section for incompatible changes, and some other section as well. But the section for new feature is very, very useful. I'm mentioning this because I know many people don't read the release notes, but they're very useful. And we spend a lot of time doing them. And then you could use your favorite IDE. Nowadays, IntelliJ and NetBeans are becoming more and more support more and more EA releases quickly. And you could subscribe to the mailing list to stay informed. So beyond JDK 13, throughout the conference, you might have heard about these project names. And our team, the language and tooling team, is involved with some of these projects, Amber, Valhalla, and Panama being some of them. Project Camber, so essentially this is the goal of Project Camber is to explore and incubate smaller productivity-oriented Java language feature. I showed some of them that are available today. I showed some of them that are our near-term roadmap, and we have many more on our long-term roadmap. Project Valhalla is to introduce value types to the platform, and Project Panama is to improve the interconnection of the JVM and native code. And I'm going to talk a little bit about Project Panama because my team is also spending a fair amount of time on that project, and that project is becoming more and more ready. So the philosophy behind Panama is to make it much easier to consume native libraries by making them look like ordinary Java interfaces, and to provide tools to make accessing native memory safer, to generate code dynamically rather than statically, eliminating brittle, error-prone artifacts, and to make it easy to package native library with tools which library developers can use to extract Java bindings from native APIs. So the status of the project, it works. It's been tested on real-world libraries such as TensorFlow, BLAS, and other machine learning-based library. So one thing about Project Panama, it's a little bit the replacement for JNI. And essentially why we're doing this, well, a good part of why we're doing this is we recognize the fact that there are some extensive amount of native library out there that are doing some very, very useful stuff, especially in the machine learning / artificial intelligence space. So the Panama feature is big, like many other projects we're working in the JDK. And as we've mentioned in the keynote and some other presentation, we need to deliver these features in stages, in much smaller pieces. And the first deliverable for Project Panama that we're working on is the Memory Access API. So a little bit more about this memory access. It's an off-heap memory access built on top of existing var-handle machinery. It's to be the replacement of the byte buffer and the replacement of unsafe. And the performance is very, very good right now. And we have a JEP, and we are pushing the JEP through the right channels in order to socialize the API and hopefully move this to a near future release. The next step in this architecture is the foreign function layer, so the ability to call native methods, and it's built on top of method handled. And the third step is the tooling support for it through a tool called JExtract. And through a tool called JExtract, you could read C header files or C++, but right now C works really well, like standard I/O, and it will generate Java interfaces that you'll be able to access the C methods directly through it. And the code to make the transition from Java to C is generated dynamically through the binder on the fly. So the goal of this layered architecture is to minimize risk and is to deliver incrementally these features. So again, you can download a little bit more advertisement here. You could download those builds from this simple website. It's a very simple website. There's not a whole lot on that website, but it contains all the essential to download the builds for the current release and for the early access build for future releases and project builds as well. That concludes my presentation. Thank you. Thank you. Questions? Oh, okay.
Can you potentially talk more about value types?
Yes, I can talk a little bit more about value types. I don't have any slides because there's been many some other presentation about it, but value types is currently, I'm going to keep it simple here. So let's assume you have a collection, an array list of objects. And the array list of objects is essentially a set of references to these objects. So therefore, it uses additional memory to point to all sorts of locations to have references to those objects. The goal of turning a collection of objects from a references to value types is to have an array list of data types directly, instead of having an array list of references to those data types. So this is a simple case. We have some demos, actually. There was a demo in the keynote that essentially converted it was a Mandelbrot demo, and it converted some main data structure inside the Mandelbrot demo from reference to inline types. And the result was, running the applications was 3 times faster, just by reducing the overhead of allocating all those references and also improving the memory locality of that data.
So it's really about kind of keeping essentially multiple objects joined together in memory, so to say, and without the overhead of object headers and whatnot. So it's really relevant when you have collections of objects or arrays.
It's really useful with arrays and collections. That's what it's meant for, yes. That's where the real performance is going to come from. Yeah. The reason why I'm not expanding too much on Valhalla is because my team is currently not the biggest focus of my team, because there's a lot of VM work that is happening right now. And once we ship the VM work, we'll be able to ship the language feature built on top of it, and the library support for it as well. Any other question? Can you use the microphone for other people? The microphone is right up there. No, if you could use the microphone, thank you. Yeah, yeah. Oh, it should work. Oh, it doesn't work? Oh, okay. Where's my audio guy? He left. Okay, so go ahead. I'm sorry.
Okay, about switch statement.
Yeah.
The new approach is applicable only when you are going to return a value.
Mm-hmm.
Why don't we consider a possibility to make it void? For example, if I want to execute in each case just some command not returning.
Okay, so the question is why, in a switch statement, we need to return a value. And then why couldn't we consider making it void, making some of those case statement voids? Well, the reason where we need to return a value is in the case of a switch expression, not a switch statement. A switch statement does not return a value. It's the switch expression part that returns a value.
In case of statement, can I apply the new format?
In the case of statement, you could use the new format of the case statement. Yes, it looks really nice as well. I just don't display all the possible cases here for the. Pardon me? Yeah, just embrace it. Yeah, yeah. So it's really nice. Yes. Mm-hmm.
So you can still write switch actually statement, but in a more compact format.
Yes, I would. Yeah, I would have liked to keep a slide for this. Yeah. Oh, yes, you can. Yes, and we believe that the new form is going to be used by 99% of the people. The old form, you really only need it when you need to break through, to fall through a case. At this point.
Why you exclude Nashorn? It's not.
Yeah, why did we deprecate Nashorn? Well, there are better alternatives out there, and Graal VM is working on Truffle.js, is a much better alternative to Nashorn. Therefore, from an investment purpose for the JDK community, what they need to invest on, what they need to prioritize on, we had to make some choices, and JavaScript 6 was a huge undertaking. So therefore, we didn't want to put all this investment in both Nashorn and Truffle.js. So we decided to focus, Truffle.js focus on keeping JavaScript up to date. And Truffle.js will soon, hopefully, be a product, and therefore it will be the replacement for Nashorn in the JDK. And the goal as well, when we're going to remove Nashorn, Truffle.js will be a module that's going to be available. You just need to download it, and you just need to reference it, and it's fine. It's much simpler. With the module system, we no longer need to ship everything with the JDK. Other question? Well, thank you. Thank you, everyone.